Yes, we are going to start with aggregate functions. So what are aggregate functions we have? We have aggregate functions like sum, min, max, average. As the name says, as the function name itself says, it's a self-description. Self-described. What is that? Sum, addition, sum means total. And next is minimum. Max is to find the maximum of the number in a given column. Minimum is to find minimum number in the column. Clear? But if you see, let us consider, we'll take one example, real-time example. We'll see the theoretical part and then we'll go to the practical. So let us consider we have a retail store in every other city. In every other city, like multiple retail stores are. On particular date, we are recording how many sales are happening on a particular date. So if you see here, this is a retail store in Bangalore on 2021 1 and 2021 2 and all, right? So we are discussing sales, what happened in Bangalore. So if you see here, on particular day, what happened, how many sales has happened is one table, and in another table, what we have, transaction. Like we are maintaining a total, okay, total transactions which happened from long, like a history is there. Okay, like a history is there. Now this is a retail store we have, and there what we have, retail store total transactions, like history. Okay, like history. So now if you take about this, if we talk about this, so now see, we may not apply this, what do you say, max and min functions, average and aggregate functions to the simple tables. We can have applied to the integer columns, but not to the string columns. You can't go and say max of name. Okay, you will apply to the integer columns or numerical columns. Okay, numerical columns. So let us open the table. What we have, table is vehicles from long, or we can take another table which may be useful to you guys also. Vehicles is the one already we have in public. Any other table do we have? We'll see. Let us see that. Do we have? I think that vehicles will also suffice for us for our example, I think. No, this may not be suffice for us. That only will be suffice for us. I think we'll go with that only. So that will be very easy for us. And we'll say it's a public one and the tables of vehicles. So where we have the data, any idea? 5. Oh, that is the biggest table. That is the biggest table, I think. I think this is also a very big table. Vehicles only we take. Yeah, vehicles only we have. Less number, 15,000. So now I want to find out total price of my showroom. Total sum, what I'm having. What is the price? Total price of the cars we have in the showroom. Like what may be the price? Total price cost I have invested on cars. So I can say sum of the price. Sum of the price. Clear? So now I want to find out maximum price. What is the maximum price? Single maximum price we have. What is the minimum, lowest car? Lowest car. Okay. So now, what is the point is we want to find out average means
divided by number of.
Divided by number of. Divided by number of. See, now it is coming like this. Okay. So now this is an additional one, not with respect to the aggregate functions we are seeing. Now we can say numeric of. Okay, not this one. We can convert it to numeric of not 5,2. What is this? 6, 7, 7 and 9. 9,2 I can specify. Yeah. Why it is 9,2? Total numbers are 9. Total numbers are 9 with precision, and precision is 2 numbers. Precision is 2 numbers. So basically, when you are creating a table itself, you should not create with numeric very large number. Tomorrow, someone may insert the data, which is very huge number, and make your UI also look awkward. So, while defining the table structure itself, we should declare with a numeric. What? With a space. What should it occupy? Maximum 10,2. Maximum. If it is like 100 marks, we have like you only have 3 digits, then you go for 5,2. What is 5,2 maximum? 100.00. That's it, maximum. Correct. You're calculating any percentage tomorrow, not only marks, any percentage you calculate. So in that case, this is the best rule. What is that? Any percentage column should have with the predefined size. Okay, that is the best practice. Without that, also it will create. What is the best practice here? You go with the size, predefined size, so that you will avoid any unexpected incidents. Okay, right. So now, if this is the case, okay.
Total and the comma after comma 2 is after top.
Correct. 10 is the total numbers. Here 9 only. No, not including dot. After dot means precision. You should say not dot. You should say it should say it as precision. Okay, precision. After the precision, 2. Okay. So now let us consider. I'll give wrong. Let us consider. I'll give wrong. What is that? We are expecting 100.00 kind of values. But what our original value is? More than this. So will it insert? No. What happened? Numeric field overflow. A field with precision 5,2 must round to the absolute value less than. It is saying the suggestion also. See, database is also as such an intelligent one, saying that. So 10,3, you should apply 10,3 at least maximum. Okay.
11.
But
11, instead of 5,
you can give any number.
We'll see.
You can give any number, man. That is not a big deal. That is not a big deal. What my point is, you have what? No, not minimum. We should give maximum only. We should give maximum only. Now, what my value was 9,2, but I gave 10,2. I'm giving maximum only. I'm expecting. I'm designing a table. I'm designing the table in such a way that size how it should be. Okay, we are not discussing about the size and all. We're discussing about the aggregate function. We'll come back to aggregate function. Okay, then we'll go to the decisions. So what is this aggregate functions? A simple ones like min, max, average. We have one. Okay, very happy scenario. Very fine. Okay, so just go back to let's go back to our this one. So you have C. Now I want to find what I want to find. I want to find out in which store the data has been more. Okay, so in which stores the sales has been more. Okay, what is the maximum sales happened in a single store? Okay, so let us consider. Let us create a table so that we can understand. Okay, so what we'll say, we'll find we need to create a retail store, right? Create a table retail stores. What is the retail store? Will have ID, primary key. Very good. Serial. Serial primary key. What is that? Store name. What is the store name? Character varying of 50 will keep. Best practice. This is the best practice. You can give without that also. Best practice. And sales. Sales may be numeric. Again, will give 10,2. Whatever the sales it may be. By 10,2 we know all. Right? So 10,2. So this is done. Right? So create table, retail, store, transactions. Okay. What is this table meant for? Serial, primary key. Okay. I want a store ID. Right? I want a store ID. Store ID, integer. Right? References. What? References. Retail store. Retail stores of ID. So this is a foreign key. Yeah, that is a foreign key. So on which date? On which date and timestamp also we want. So what we'll do? So we'll say date. No, date. Or what is a transaction date? What is that? Timestamp with time zone. Right? And timestamp with time zone is there. Yeah, that is enough, I think. Maximum, and this is enough, I think, right? So I'll create this also. Yep, done. So now what we need to do? We need to insert the data. Insert the data. What is that? Retail store first we need to do. Insert into retail store. What retail stores will have? Store name, comma, sales. That is the column names, is it? Yes, obviously. Values we can say as we've got sales around 4,000. Till now, what happened? Till now, what happened? So we will say like that. We can mention how many? Done. So we have the table now. Say from retail stores. So now we'll say retail store is the data we have. Super. So now apart from retail stores, where we need to insert the data? Transactions. So now you see from this lesson, you should revive all the classes what we have done. So retail stores. In retail stores, we need to insert the data. Insert into Insert into what transactions? Okay, what I'll do, I'll before retail store transactions. So what should we have? Store ID, transaction date. That's it. Transaction date. Let's copy right. That's fine. So we'll say store ID. What is the store ID? How many store IDs we have? 5. Okay, nice. And transaction date. So what happens if I give you a transaction date as a store ID of 6 and put a transaction date of now? Will it work? Why? So let's say foreign key constraint. So that's the bottom. What we'll do? 5. But we need to add one more column, right? How many sales has been happened on that particular day, right? So on that particular date, so add alter table, retail store, add column, very good, number of sales. What is that number of sales? Primary key, not numerica, 2 and half item. So now we need to add, what is that? Number of sales. Now we will say, so now what is the 5? 20,000. So today we'll say 100. It happened in that. Clear? So we have inserted. We'll say 4. How many? 1,000 we have. So this is also will say 100. Okay. Say now minus 1. We'll say 500. It happened. Minus 1 illantama. Minus 1 is not there. Explicit type cast on that. So okay, we'll add like this. What is that? Today is 6th. Today is 6th. So we'll say 5. What is that? 0, 1. 0, 5. So will it work out? Yes, worked out. So now this is 5, like 4 and 4, like 1,000 was there. 100 and 500 is completed. So we'll change to third date. Again 400 or like 200 we'll say. So that is another one we have. Okay. So fine. We will go with the Flipkart first one. So on that day we'll say 2000 has happened. We'll go with the second one. We'll say 2500 has happened. Right. We'll go with the third one. What we'll say 1500 has happened. Date elladukku third. Now we will change. So today we'll mention it as. Okay, now this today. Like 1. So we'll mention it as again 1500 to all. So now our to store transactions, what it will have, we'll see. Okay. So what is our to store transactions? Do we cover? Did we cover everything here? We need to see. So maybe wrong also, but the exact numbers we have not done. But did we get store IDs of 1, 2, 3? 3 we didn't get. Oh, 3 also we got. Sorry, 3 also. Yeah, 3 also we got, right? 3 also we got, and 3 2 times we inserted. Oh, different dates. Very good. That is different. That is different. See, now when we see now that exact timestamp is also coming. Okay. So we'll say for one now is not there, no? For which and all now is not there. That also will add. 4 5 now is there. Correct. 4 5 now is there. So what we'll do? Now 4 5 only is there. 1 is not there. 2 is not there. 3 is also not. Fine. So now we have inserted the data with the timestamp. So what happens to the 1 or 5? Yes. So we got all the data. Right? We got all the data, all the storages. So we have this kind of transactions. So let us consider we don't have a total transactions. We want to find out. We want to join the two tables and find out in each store total sum what happened. Right? So what is the point? We have a retail store. We said this retail store is there. So retail store table is R1. We'll say RP1. This is alias name as T1 as T2. How can we join? T1.id is equal to T2.store id. Right? We are completing the joins also. But what we want store name, okay, store name, comma, number of cells. Number of cells. What happened? Where condition? Where condition? Where we should not say. We didn't say. Right? This is what happened. Correct. Now, what we need to find out? Total cells. Total cells. First of all, we'll find the total cells of the table. Total cells. What we'll say? Sum of number of cells in all retail shops. Now, all retail shops. Total transactions in India. Let us consider. Oh, this many. Total transactions in India. Very good. No. I want to find out in every store total sum. So again, we will say sum. This is a very important point. Please concentrate on here. Sum, okay, sum or average or anything. Okay, I want to find out. What happened? So whenever you are using another column along with the aggregate function, another column, you should use group by. Use group by store name. So automatically just calculates the total value sum. So now same thing. What will happen again? Sorry, we'll copy this. So now rather than this one, what is the minimum sales in every shop? And which day it is happened also you can find out. And which day it is happened means transaction date. Where is the transaction date? In T2, right? So transaction underscore date, right? Correct? Is it the name correct? Transaction underscore date. So now what happened? Again error will come. Why? Your transaction date is not mentioned in group by. You have mentioned only what? But we are using, so how many ever column, whatever the columns you use along with aggregate functions, we use group by. Okay, we should have in in group by. We use a we should have it in group by. Clear? Should have it in group by, because dates are different. On that particular date, the minimum sales was this. The particular date and particular time. So date is not a correct option here, but just we'll find out what is the minimum number of sales for that. Clear? So min, max, average, sum, everything is done. Right. So one point you need to remember, whenever you apply aggregate functions along with other columns, what you should do? You should use group by. You should group the values, no? We should use group by, so that the total will be perfect and correct. So now we can apply one more point here along with the group by. I want the sales. I want a store, retail stores, which is having the sales greater than 1,500, greater than or equal to 1,000. Okay, what we'll say? Having number of sales greater than 1,000. We'll say 1,000 first. So what happened? So now it is expecting number of sales also must appear in the group by. Okay. I got only the sales which are above, which are above all the sales I got. Okay, but date is there. All the sales which are above 1,500, and the minimum value on that day. On that day, many transactions can happen. Correct. One guy can purchase 100, 500, 2, 3. That is also there. Just on the transaction day, what happened is what our table is. You don't worry about the table, we worry about the concept. What I'm saying, we want to find out minimum values. Okay, minimum value you find out, but if the value is more than 1,000, who all I have done? Because if it is more than 1,000, the money matters. So you need to apply some rules. Correct? Your taxation may be different. Correct. So we'll say, okay, more than 1,000, whoever have done, I will pull out and I'll say, boss, you have done more than 1,000, you need to pay this much amount. Okay. Or we will send, like he has done so many transactions, we will send a token of appreciation to him. Cashback or something else. If you purchase 1 or 2, why, correct? Like that. Clear? So group by and having. So you should not, we can't use, okay, we cannot use having without group by. Can we do a, we'll see. We can't do, no? But if we remove this, and if I say this, is this possible? So I want to join two tables. I want to bring out all the store names whose sales is greater than. For that, why you need having? You can say where number of sales is equal to greater than 1,000. That's simple, right? Group by and having goes hand in hand. Okay, both comes together and goes together. Clear? Is it clear? No, it says group by. So rather than that, what we have told is just told and we'll bring that. All got. Clear? That's it about the average functions, aggregate functions. The aggregate functions is very, very important topic. What is happening here? We should have a non-aggregated column in group by, for sure. Non-aggregated column in group by. Okay. We are using a non-aggregated column along with the aggregated column. That non-aggregated column should be there in a group by. So as you saw earlier. Right.